Hi everyone, in this video we're going to go over another Leetcode question, search in rotated sorted array 2. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. 0, 0, 1, 2, 2, 5, 6 might become 2, 5, 6, 0, 0, 1, 2. So this is the pivot point and these three numbers go to the beginning. So this is rotated. You are given a target value to search. If found in the array, return true, otherwise return false. I also recorded search in rotated sorted array 1 question. If you want to see that one first, then come to this question. It's completely up to you. I'm going to solve this again, explaining everything. So example 1, we have this array and target is 0. We have 0, so we return true. Example 2, 2, 5, 6, same array, target is 3, missing, so we return false. This is a follow-up problem to search and rotate a sorted array where nums may contain duplicates. So we have duplicates in this question. For example, 0, 0, 2, 2. That is the difference. That is different than the first version. Would this affect the runtime complexity? How and why? Okay, let's get on the whiteboard and try to solve this question. So we have the function here. We are going to implement binary search again. Binary search is a divide and conquer algorithm where we divide the array by 2. As it is sorted, we can only look for certain parts of the array. And that will save us quite some time, and we can reach logarithmic time complexity over linear time complexity. So it's much better than linear time complexity, and it's basically divide and conquer algorithm in short. So here we have an array. This is a start point and end point. While end is greater than start, this is a condition for binary search, we find the midpoint, and that is start plus end minus start divided by 2. You can say start plus end divided by 2, but that may cause integer overflow. To avoid that, we say start plus end minus start divided by 2. So we are looking for the target number using the binary search, right? So if nums of mid is target, then we return true. For example, we are looking for the target value 0. If nums of mid, in this case 0, is equal to 0, the target we are looking for, then we return true. Excuse me. So we return true here. Otherwise, we continue. Let's say we are looking for target 5. Okay. So we have two conditions here. We need to find which part of the array is sorted and which part of the array is unsorted. And to check that, we have an if check here. Nums of start is less than nums of mid. That is how it should be. Like, if nums of start in an ascending order array, nums of start should be less than nums of mid. But this array is rotated, so let's see if it's sorted. Is nums of start 2 is less than nums of mid? No. So nums of mid is less than nums of start. So nums of start is greater than nums of mid. And we implement this part. Right? So we are working on the unsorted side of the array. And we are working on this side now. For example, I could have said this. A mid would be, in that case, this. So then this part would be sorted, and this part would be unsorted in that case. because medium is greater than the end. That is awkward. That is something wrong about this array. So this part is unsorted and this part is sorted, right? So that is what we are checking. Which part is sorted, which part is unsorted. So our target value is 5. Then we check nums of start is greater than nums of mid. Okay, so nums of start is greater than nums of mid. We have the unsorted start side, and we are looking for our number here. So we are checking target is less than nums of mid. 5 is less than nums of mid. That's false. Or target is greater than nums of end. Greater than nums of end means this. Before this array is rotated, it was something like this. If this wasn't rotated, don't see this part, it was going like this, right? So nums of mid, so target that 5 is greater than nums of end. That is the case, yes. But this part is rotated to this side, okay? So between our mid number and start number is the number we are looking for. And that is the case, yes. So we are looking for here, this part of the number. And to do that, n becomes medium minus 1. And our new medium becomes here. And is this the value we are looking for? Yes, so we return true. That is as simple as it is. If none of them works, if it breaks, if, for example, we have duplicates like this, we have a start value that we increment the start value until we find the number and until we find the end. So that is the else statement. That is the tricky part of this question. We increment the start value if none of these two steps work. Okay, like nums of start is less than nums of mid, or nums of start is nums of mid greater than nums of mid. None of them works, and that in that case we have duplicates. So we simply increment the number, our start, until we find to the point. So in every iteration, we increment start until we get to the point where one of these if checks works. And this is the worst case scenario. In that case, your time complexity will be affected as O of n, and that's what the question is asking here. So in that case, you need to go through all the elements here, like considering you're doing binary search, you will still reach linear time complexity. That is what it was asking. So I hope it was clear. Let's see another. Excuse me. Let's try another one. Let's remove this one and make right side unsorted. So we have this array and we are looking for number 1. Cool. So what we do is, and we can also look for number 2. That would be the next thing we can do. So nums of mid is greater than nums of start. That is the case. We are on the sorted side. Start goes to the mid. That is sorted. That's what we want, right? So we are looking for this side here. This part of the if check. So target is less than nums of start. So 1 is less than nums of start, yes. Target is greater than nums of mid, no. In that case, we say mid plus 1, because we are on the sorted side and this part is unsorted, so the number we're looking for, if it is less than the target, so if less than the start, that means this part is coming from this part of the array, right? So the number I should be looking for on this side then. So what I do is I simply move my start here. And when I do another binary search in the mid, that will give me nums of mid, gives me return true. I hope it was clear. So if the number I'm looking for is less than start, then it should be on this side. Because if it was like this, it would be easier to say it's just this side I'm looking for. But we are simply doing the other way around. So it should be before. Before this is happening on this side, because this is the unsorted side. So we are looking for this part. Let's check the target too in this case, right? So medium is here. Our nums of start is less than nums of mid. That's the case, yeah. Target is 2. Target is less than nums of start. False. Target is greater than nums of mid. That is also false. So we say mid minus 1. And goes this way. And then we find the result. So this is pretty much the idea. You just need to play around with it a little bit. Just in your mind, just put this 3 numbers at the end of the array and think about that way. So then that will make sense to you. The whole thing will make sense to you after that. I hope I was clear here. Let's go to the code. This is how it looks in the code editor. So checking which part is sorted, which part is not sorted, and incrementing if there are duplicates. This is the difference here than version 1. We have an else statement. If you have duplicates, we are incrementing the counter. So let's submit. Okay, this is interesting. It was 2 milliseconds, 1, and finally 0, and it worked. So this is pretty much it for this question. I hope I made it clear. It's a little confusing, to be honest, but I try to simplify it as much as I can. I hope it was helpful, and I have more videos coming up. So if you subscribe to my channel, and if you also hit the like button, I would appreciate it. If you subscribe to my channel, we can meet again later. Thanks for watching. Goodbye.